All right, moving on to Unit 5, we are looking into data and statistics. So Unit 5.1 is going to be all about designing a survey and making sure that our surveys are correct and can give us some good data. So let's first go over some terminology here, some vocabulary. When we're designing a survey, some things to keep in mind. A population is the entire group of individuals about which we want information in its statistical study. A sample, on the other hand, is just a part of the population from which we actually collect the information. We use a sample to draw conclusions about the entire population. So down here, this graphic will kind of show you the difference between a population and a sample. The population is the entire group we are interested in looking at, but we can't actually ask every single person. So an example would be like all human beings. You can't ask a question to every single human being. Or maybe all working age people in California. You can't ask everybody the same question. Or all crickets. Again, we can't test every single one of them. But a sample, on the other hand, is just a part of that population that we can actually examine and for which we can get some data. So we can ask, some people who are working age in California. And as long as we have enough of them, we can say that our data holds true for that group. Or we can ask people from all over the entire world. And again, as long as we hit enough places and enough people, we can say that it applies to all humans. Now, how well the sample represents the population depends on how well the sample was designed. A parameter is a number describing a characteristic of the population. Parameter P goes with population P. A statistic is a number describing a characteristic of a sample. S and S. Okay, now I won't read through all of this piece here, but these were, again, quotes taken directly out of some other more statistics-based textbooks. That's why the source was cited here at the very bottom. So it's the Best Practice of Statistics, 4th edition by Moore in 2008, page 189. So this was a really good textbook that gave us some things to read over. I'm going to go back then to the top here. We're going to look at some more of our vocabulary. A convenience sample. There are actually 5 different kinds of samples that we're going to look at today to describe how well a sample is created. A convenience sample is a sample that is taken in a way that is easiest for the one taking the sample. And you'll see some examples of what we mean by this. But basically it just means whoever was taking the sample found a few people that were easy to get to and asked them a question. Cluster samples is a sample that consists of items in a particular group. So let's say we wanted to talk about the population of the entire high school, but we only asked freshmen. So it just comes from one group, so that's a cluster sample then. A stratified random sample. It's a sample selected by first classifying the population into groups of similar individuals called strata. Then you choose a separate SRS. This SRS stands for simple random sample. It's this one down here, number 5. In each stratum and combine these SRSs to form the full sample. So again, in this case, a stratified random sample, kind of like our cluster sample, would be if we wanted to know something about an entire high school. So we asked a certain amount of people from the freshman class, the sophomore class, the junior class, and the senior class. So still everybody was represented, but we kind of broke it down into groups first before we randomly selected them. So as long as everybody is still represented there, that would be a stratified random sample. A systematic random sample would be a sample chosen by using a system or method that creates a randomness in who gets chosen. So an example of this would be like saying we have a big alphabetical list of everybody in the school, and we wanted to choose every 5th person. Now, as long as we're choosing the same system, every 5th person, that will generate a random sample. The problem is, when you go every 5th person, say there are 2 people whose names are right next to each other, there's no possible way those will ever be chosen together, which means you're excluding a group of people, everybody whose names are right next to each other. they'll never be able to be represented together. So it's not a truly simple random sample. And that would be the best form of a design, would be an SRS, the simple random sample. It's a sample of size n. It consists of n individuals from the whole population, chosen in such a way that every set of n individuals, or every group of people, has an equal chance of being selected. Now again, this would be something like you have a list of every student in the school, and you somehow rolled the dice or found a way to use a calculator to generate some random numbers that would randomly select everyone. So everyone still has an equal chance of being selected together. It wasn't every fifth person, or it wasn't, so many from the freshmen, so many from the juniors. It was everybody has an equal chance of being selected in there. That would be a simple random sample. Now, some other things to look into are a biased sample. Now, this is any sample. We would consider it biased if it systematically favors certain outcomes. So a convenient sample, and sometimes even a cluster sample, would be considered fairly biased. For some reason, those ones will systematically favor one outcome or another. And we'll see what that looks like in some of our examples. Undercoverage or underrepresentation. Undercoverage occurs when some groups in the population are left out of the process when choosing the sample. So undercoverage would be like we weren't able to choose any juniors or any seniors when we were trying to look at all of the high school. That would be undercoverage. That whole group is left out. Underrepresentation occurs when an individual chosen from the sample can't be contacted or refuses to participate. So one person wasn't able to get their data into the whole sample there. And a voluntary response. It's another kind of sample. Consists of people who choose themselves by responding to a broad appeal. Voluntary response samples are biased because usually people with strong opinions are the most likely to respond. It would be like if you set up a table outside of the lunchroom and ask people to respond to a certain question. Usually, the people who are most likely to respond are the people who are going to be the most mad one way or the other. So normally you don't get a whole lot of people who are mediocre or in between to respond to something like that. So voluntary response is fairly biased because you only get strongly opinionated people to respond to that. So let's look at some examples here. The mayor of the city asked the principal to select a panel of 20 students to give impressions on youth programs. So the principal stands by his office and asks the first 20 students he sees. What kind of sampling method did he use? Well, this would be, again, what we call the convenient sample. He just kind of randomly stood there, and the first people he saw, that's who he chose. It's very convenient for him because it's not necessarily random. Who might be underrepresented in this sample? Who doesn't really get a voice in this case? Well, that would be any student whose classes are not near the principal's office. If they weren't walking near his office, he wouldn't have had a chance to ask them if they want to be a part of this. So students whose classes are not near his office would be underrepresented in the sample. So that shows there would be some bias in a convenient sample. Let's look at some other examples. What kinds of samplings are these? So let's say every student got a 3-digit ID number. So something like 001 or 898. Everybody got a 3-digit ID, and then we used a calculator to generate 20 random numbers. This would be a simple random sample. This is a very good form of taking a sample, or picking a sample at least, to be able to ask people something, because everybody has the same probability of being picked. Everybody has an equal chance to be a part of this sample. Let's look at B though. Random numbers. It's a random number system to pick 5 freshmen, 5 sophomores, 5 juniors, and 5 seniors. So this isn't everybody in the whole group. It's just 5 freshmen, 5 sophomores, 5 juniors, 5 seniors. So we kind of break it down into groups first. Because it was broken down into groups first, this would be a stratified random sample. It's still randomly selected. So we used random numbers again to pick the 5 freshmen, the 5 sophomores, 5 juniors, and 5 seniors. But because we had to kind of put them into groups first, those would be our stratified random sample. So it's random, but there's still groups in it. How about this one? C, we randomly pick a student from an alphabetical list of all the students, and then we say every 20th student after that person. This would be a form of the systematic random sample. It's still random because there isn't anything that chooses or leans more towards this group or that group. It's still going to be randomly selected, but because there's not a chance that two students who are alphabetically right next to each other, they will never be able to be chosen in the sample together. So it kind of rules them out. So it's not a truly simple random sample, it's systematic. It says every 20th person or every 5th person. There is a certain system that picks all the students, but they are still randomly selected. And we say that we randomly pick 20 students getting off the bus in the morning. This one is technically a convenience sample because technically not every student will use the bus. Not every student takes the bus in the morning. So we only ask students who are getting on and off the bus, so it's just very convenient or very easy for the person who is selecting these people. Are any of these sampling methods biased? If so, who is represented? Yes, D is definitely biased. Anyone who doesn't ride the bus would be underrepresented. So if we were going to ask all of these students, are you satisfied with school lunches? Well, there's a lot of students who didn't get asked them, and a lot of students in certain groups who didn't get asked. Anybody who doesn't take the bus, they didn't even have a chance to get sampled or to be asked that question. Only the people who rode the bus were. So yes, this would definitely be biased against people who don't ride the bus. So let's look at some bad sampling methods. Convenient sampling is definitely bad. Why is it considered bad? It's considered kind of the man on the street survey. It's cheap, it's convenient, it's often quite opinionated or emotional. It's actually very popular with TV journalism. Sometimes you'll see people on TV like reporters or people like Jay Leno who will go to the streets and start asking people questions. It's just easy for them to find somebody, but you can't necessarily take what they say as being a good sample. We can't necessarily say that what is said on there, even if like 70% of the people say the same thing, they just found easy people to ask, so it doesn't necessarily count. So for an example, if you ask about gun control or legalizing marijuana on the street in Berkeley, California, versus if you go to some small town in Idaho, you'd probably get some very different answers. So convenient will not give you a very good answer or very good solution. Those sampling methods are not the best. Even within a certain area, answers would probably differ if you did the survey outside of a high school or outside of a country western bar. People are going to give you different answers based on where they are at or what's going on. You have to make sure they are completely random as best as you possibly can. The bias in this case, the opinions will be limited to individuals present. So again, like the bus one, you'd only be asking students who take the bus. Anybody who doesn't take the bus wouldn't get a chance to be a part of the sample. Another bad sampling method is the voluntary response sampling. Why is it considered bad? Individuals will choose to be involved, which means they also choose not to be involved. So these samples are very susceptible to being biased because different people are motivated to respond or not. They are often called public opinion polls and are not considered valid or scientific. So for an example, Ann Landers summarizing responses of readers, she says 70% of 10,000 parents wrote in to say that having kids was not worth it. If they had to do it over again, they wouldn't have kids. Now, normally, people who write into letters to the editor, like this Ann Landers, they're only people who are going to be very, very angry or very emotional about a certain subject. So if you get 10,000 of these angry people to call in, people who are very, very passionate about what they have to say, then yeah, it might make sense that 70% of them are angry about something, or they feel strongly one way or another. The bias, most letters to the newspaper are written by disgruntled people. A truly random sample would show that 91% of the parents would have kids again. So most people who are content with their lives, or most people who are happy with what's going on, they don't need to write into somebody like Ann Landers. They don't really care. It's not that big of a deal. So if you truly got a random sample, actually 91% of them say they would have kids, whereas in this case, 70% of them said they wouldn't. So the data is very, very different based on who is calling in or who is answering and why. Here's an example of a voluntary response, something like online surveys. Again, the bias is that people have to care enough about an issue to bother replying. So here's an example right off the internet. Is the expense of trying to rescue a dog aboard an abandoned ship near Hawaii justified? Now, who's going to take the time to actually answer this? People who really actually care. Who's going to not answer it and just kind of walk away? People who really don't care that bad. So really, you're just going to get a lot of very opinionated people. Now, it even says on here, this quick vote is not scientific and reflects the opinions of only those internet users who have chosen to participate. These results cannot be assumed to represent the opinions of internet users in general, nor the public as a whole. The quick vote sponsor is not responsible for content, functionality, or the opinions expressed therein. So even though it looks like 59% of the people said yes, they should do it, and 41% said no, it's not worth it, that's not a very good sample. It's not a justifiable way to get information. In our next video, we're going to look at good sampling methods then, but let's wait until a second video.